Alright, so this is part 2 of the Honors Section 16.2 lesson video. I did not realize there was going to be a part 2. Apparently my camera died partway through the lesson video and I didn't realize it. So here comes part 2. So if it cut off at an awkward time, it's because my camera had died. So as I was discussing in the previous video, that you add more solvent to a solution in order to dilute it. So the number of moles of solute remains the same. So for example, say you buy a tiny packet of Kool-Aid and powder and you think it's for a glass of Kool-Aid, but really it's for a pitcher. So you dump the whole thing in the glass and then when you taste it, it's too strong. Well, what do you do to dilute it? Well, you add more water, but you didn't actually lose any of the Kool-Aid powder, so the solute stays the same. So for a dilution, you add more solvent. So our formula is M1V1 equals M2V2. M are your molarities. They have to be in molarity or moles per liter. And so, of course, M1 is more concentrated and M2 is more dilute. So your M1 should be larger than your M2. And then V1 and V2 are your volumes. They can be in milliliters or liters. It doesn't matter because the units will cancel. So let's look at how to use this formula. So it says, how many milliliters of aqueous 2 molar MgSO4 solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar magnesium sulfate. So we're looking for our V1 in milliliters, and they gave me my M1, they gave me my V2, and they gave me my M2.
Mr. Warren, please contact the front office. Mr. Warren, please contact the front office.
So our formula is M1V1 equals M2V2. So I'm solving for V1, so I divide both sides by M1. And then I'm just ready to plug in. So my M2 is 0.4 molar. My V2 is 100 milliliters. And my M1 is 2 molar. So my molarities cancel. And when I solved on this one, I got about 20 milliliters. So what that means is I need to start with 20 milliliters of 2 molar magnesium sulfate. And then I need to add 80 milliliters of water. The reason I say 80, because I know I'm pointing to 100, is that's with the 20. Like we dilute it to a volume of 100. So I add 80 milliliters of water. And then that will reduce the concentration down to 0.4. Alright, so let's see if you can do these on your own, because of course that's what's important. So y'all try these two, pause it, try it, and then we'll go over it together. So it says how many milliliters, so I'm looking for V1 again, of a solution of 4 molar, so there's my M1, potassium iodide, are needed to prepare 250 milliliters, so there's my V2, of 0.76 molar potassium iodide, so there's my M2. So again, we're solving for V1. So I'm going to divide both sides by M1. And then I just plug in. That basic algebra math is always the easiest. So I have M2, 0.76 molar, times V2, which is 250 milliliters, divided by M1, which is 4 molar. So my molarities cancel, and so when I solved, I got 47.5 milliliters. So hopefully you also got 47.5 milliliters. Alright, and number 2, if you tried this one on your own, you probably got the number answer, but you may not have done the sentence answer that really goes along with it. Now, because I didn't give myself a lot of room, I'm just going to verbally say the sentence. But just know that, you know, if this was like a worksheet or something, you would need to write the sentence on there. Because it asks how would you prepare. It doesn't just say how many milliliters where I can give a number answer. It says how would you prepare. So let's look at this. It says how would you prepare 250 milliliters of 0.2 molar sodium chloride. So in other words, we're preparing this. So these aren't my 1s. That's not my M1V1. That's my M2V2. So here's my V2. Here's my M2. Now the good news about this formula is if you accidentally call these the 1s, you still get the right answer. Okay, but I like to plug it in the way it's supposed to. So since we're preparing these amounts, these are my 2s, of sodium chloride using only a solution of 1 molar. So there's my M1, sodium chloride, and water. So what are we missing? V1. So if you notice, it didn't actually ask for V1 anywhere in the question, but I can see that's the only part that's missing. Alright, so I plug in my formula. M1V1 equals M2V2. I'm solving for V1 again. And you don't always have to solve for V1. That's just the most common thing to solve for. And so then I just plug in. So my M2 is 0.2 molar. My V2 is 250 milliliters. And my M1 is 1 molar. So once I solved for that, I got 50 milliliters. But the thing is, the question says, how would you prepare? So like I said, you couldn't just stop at the 50 milliliters. What you would need to say is you need to start with 50 milliliters of 1 molar NaCl, dilute it with water until it has a total volume of 250 milliliters, or you could say add 200 milliliters of water, that would be fine. And that would reduce your molarity. Okay, so make sure that you would add some sort of sentence, 50 milliliters of 1 molar NaCl, either diluted to 250, or you could say add 200 milliliters of water. Either one would be fine. All right, so hopefully you got at least one, but preferably both of those right. So let's move on to percent solutions. So percent solutions work just like any percentage. It's the part over the whole times 100. So we can either do percent by volume or percent by mass. And the only thing that's different is volume uses volumes and mass uses masses. So the way you'll see me write this formula is I'll just say percent equals solute over solution times 100. And if they give me volumes, I'll plug in volumes. If they give me masses, I'll plug in masses. Okay, so it's the volume of solute over volume of the whole solution, not the solvent. All right, so let's look at how these work. So it says, what is the percent by volume? So in other words, I'm looking for my percentage of ethanol in the final solution when 85 milliliters of ethanol, so there's my solute, is diluted to a volume of 250 milliliters with water. So there's my solution. All right, and remember, abbreviation for solution is just SOLN. So I'm looking for my percentage. So remember, percent is solute over solution times 100. Now, some of you'll have trouble figuring out which one's the solute and which one's the solution. Well, remember, the solution always has to be larger because it's the total amount. You can't get over 100%. That doesn't make any sense. So I'll plug in my 85 milliliters of my solute, which is my ethanol, over my 250 milliliters of my total solution times 100. And so those milliliters cancel. And so once I divide and multiply by 100, I got 34%. So that means 34% of my solution is ethanol, the rest of it is water. All right, so let's see if you can try some of these, because again, it's just easy, plug it in. Sometimes you may have to rearrange the formula though, so we got to be careful of that. All right, so it says, so y'all pause real quick, try this, and then check your answers. So let's go over it. A bottle of hydrogen peroxide is labeled as 3%, so they gave me the percentage this time. How many milliliters of hydrogen peroxide? So this time I'm actually looking for the solute instead of the percentage. Are in 400 milliliter bottle of this solution. Now you may think, well, how do I know this is solution or solute? Well, if you read 400 milliliter bottle of this solution. So that's how we know this is the solution and not the solute. All right, but we got to rearrange the formula this time. So let's go over how to do that. So percentage is solute over solution times 100. If I solve for solute, I'm going to divide both sides by 100 to get rid of that, and then multiply both sides by solution to get rid of that. So see how my hundreds and my solution cancel? So since there's a lot going on here, I'll rewrite this one as solution times 100, whoops, sorry, not 100, times percentage over 100. And then I just plug in. So my solution is 400 milliliters. My percentage is 3%. If you want your units to work out, you can just call that 100%, because then once you plug in that 100%, the percentages cancel. And so once I solved, I ended up getting 12 milliliters. Now, some of y'all, you like to move the decimal over twice and change the 3% to a decimal form before you plug in. That's fine if you do that. But if you're going to do that, don't divide by 100, because then what you've done is divided by 100 twice, and you don't want to do that. All right, so hopefully you got that one right. So let's look at our bottom one. It says, suppose you want to make 2,000 grams of a solution. That's how I know this is solution. Of glucose in water that has a 2.8% by mass concentration. So I have my percentage. How much glucose should you use? So again, we're going to solve for solute. Now, because I just rearranged the formula for you up here, I'm just going to plug into that same formula. If you need to see me rearrange it again, obviously you can just rewind the video. All right, so my solution times percent over 100%. So my solution is 2,000 grams. My percentage is 2.8%. and then I divide by my 100%. Those percentages cancel, and when I solved, I got 56 grams. Okay, so that means I would need to take 56 grams and dissolve it in enough water to make 2,000 grams overall, and then I would have a 2.8% solution. All right, so hopefully you got at least one, but maybe both of those correct. And so let's go ahead and finish up. I really hate that I already did all of this, but my camera died. Oh well, that's fine. Hopefully it's not going to die this time. So how do you calculate molarity of a solution? Well, if you remember from the very beginning of the lesson video, molarity is moles of solute over liters of solution. Make sure you know the difference, okay? It's not moles of solute over liters of solvent. Moles of solute over liters of solution. Number 2, compare the number of moles of solute before dilution with the number of moles of solute after. The number of moles is the same. So remember the Kool-Aid example? To dilute it, you added water. You did not take away any of the Kool-Aid powder. So maybe just write yourself a note. You only add solvent. Okay, so something is changing in a dilution, but it's not the solute, it's the solvent. All right, so number 3, it says calculate the molarity of a solution containing 400 grams of copper 2 sulfate in 4 liters of solution. Okay, so we're doing molarity. So remember, molarity equals moles over liters, but the problem is I gave you grams, of course. So 400 grams of copper 2 sulfate, so of course we'll do our molar mass, which when I added up molar mass, I got 160 grams. And that of course equals 1 mole. So when I divided, I got 2.5 moles. So now I have moles, and if you look, they gave me liters right here. Okay, so then I can plug into my formula. So I'll just do it down here. Molarity equals my moles, which is 2.5 moles, divided by my liters, which is 4 liters. And so once I divided, I got 0.625, and then my unit is molarity, or of course moles per liter. Remember, either one is acceptable. All right, so I'm going to erase this so I can work out the next one. So it says how many moles, so this time I'm solving for moles, of solute are present in 50 milliliters of 0.2 molar KNO3. Okay, so I got to change my milliliters to liters. So we get 0.05 liters. And I have to rearrange my formula. So remember, molarity is moles per liter. So if I want to solve for moles, I multiply both sides by liters. Since I already showed you how to rearrange that, I'm not going to show you again. Just multiply both sides by liters. And then you just plug in. So my molarity is 0.2 molar. My liters, we changed to 0.05 liters. And so then once I multiplied and divided, I got, or there's no dividing this time. Once I multiplied, I got 0.101 moles. Because remember, molarity is moles per liter, and so the liters will cancel. All right, so let's go over those last couple real quick. That was dilution and percent, just to make sure you got those. So it says how many milliliters of stock solution, so we're looking for V1 again, of 2 molar, so there's my M1. KNO3, would you need to prepare 100 milliliters, so there's my V2, of 0.15 molar, so there's my M2. So of course we know M1 V1 equals M2 V2, so again we're solving V1, so we just divide both sides by M1. And then I just plug in, so my M2 is 0.15 molar, my V2 is 100 milliliters, and my M1 is 2 molar. Like once you label, it makes it really easy to just plug in. So, sorry, that equal sign was terrible. And once I solved this one, I got 7.5 milliliters. Okay? And so then let's just look at those percentages again, and then we'll be done with this section. So it says, what is the concentration in percent by volume? So in other words, here I'm looking for the percentage of a solution containing 50 milliliters of diethyl ether, so there's my solute, in 2.5 liters of solution. So what's the problem with this one? I have liters and milliliters, so you got to change one. Since we've been working on changing milliliters to liters anyway, I'm going to change this one by moving my decimal 3 places. So now I have liters and liters, which is what I need so they can cancel. So if you remember, percent is solute over solution times 100. So I just plug in. So my solute is 0.05 liters. My solution is 2.5 liters times 100. And so if you look, those liters cancel. See, if you had had milliliters and liters, it would not cancel. All right, and I end up getting about 2%. So 2% of my solution is diethyl ether. The rest of it is water. All right, and then last one. So it says how many grams of K2SO4. So here I'm looking for my solute. Would you need to prepare 1,500 grams, there's my solution, of 5%, there's my percent, solution. Okay, so see, again, if you didn't realize that 1,500 grams was solution, if you're thinking, well, how did you know that? If you just keep reading, 1,500 grams of 5% K2SO4 solution. That's how I know that one's solution. Now, again, on the previous slide, I already showed you how to rearrange this to solve for solute. So I'm just going to put it over here for us. So it's the percent times the solution over 100. And so then I just plug in. So my percentage is 5. I have 1,500 grams of solution, and I divide that by that 100 percentage. The percentages cancel, and when I solved, I got 75 grams. All right, so sorry again, this was broken into 2 videos. My camera died. And so hopefully this was helpful, and then I will also, if you want to continue, have the 16.3 lesson video up if you want to watch that.